Bhati with mentor Abhila Sarkar. We are progressing on time and work problem solving session. There we have reached till 28. Now onwards, I'll move on to 29. X minus 2 men can do a piece of work in X days. Can do a piece of work in X days, and X plus 7 men can do, and X plus 7 men can do 75% of the work of the same work in X minus 10 days. Then in how many days can X plus 10 men finish the work? Okay, so let us understand this problem together. Okay, let us understand this problem together, where it has said X minus 2 men can do a piece of work in X days. Okay, and X plus 7 men can do 75% of the same work in X minus 10 days. Then how many days this person X plus 10 men will take? So now we will solve it in both the manner, unitary method and the method we have adopted earlier, because you need to know both the method very well, and at least knowledge wise you have to be acquire that skill how to solve in both the way, and conceptually how that thing process. Now it is up to you or further which method you will do and what is the most comfortable method to adopt for solving problem. But at least you should know the process. So that's why from initial the earlier classes I have started solving it with the method of unitary method. Earlier every problem I did in a single method, that is calculating the rate of work, and on that basis everything being calculated. So that was the process we have learned already, very well we have learned. Now we'll move on to the unitary method first, then parallelly I will show you that, but you need to understand the concept. So concept is that in unitary method slowly you have to bring down the variable, independent variable to 1, then after to the exact requirement. So as per that, X minus 2 men, I'll say men, can do a complete job in X days. Okay, this is the first statement. So now I have to bring that the independent variable to 1. So how much one man can do? So really, if we say this is some quantity which are doing in X days, and meant to days for a particular work is inversely proportional, means if men comes down, days will go up. So it is coming down to 1. To complete the same job you need more days. Okay, this much days. Now I am to reach there. For that slowly I will reach to this man, then after I will reach to this work. So x plus 7, now men are increasing, so my target job has to be completed in lesser days, definitely. So this will be divided. So go on thinking, means how will it relate to the dependent variable. So independent variable is coming down, so days will increase, then going up days will decrease, definitely. Now if the same number of men will do the lesser job, that means 75% of the job means 3/4 of the job they are doing, so definitely the number of days will further come down. So, or you can think like that, if one is done by these days, so 3/4 of them will do in these days. These are directly proportional. Here job to days, more the job, more the days, lesser the job, lesser the days. So you see, you can say that lesser means you have to divide. You may say that why it is not divided. See, this will be divided if it is inversely proportional. This, if it is increasing, then only you are dividing, as because these are inversely proportional. When two variables, let's say A and B, are inversely proportional, so then while this is increased, this will be decreasing. This has to be decreased. So this has to be come in denominator. You have to do something variable in denominator. But if A varies B, directly proportional, when this increasing, this also increases. This decreases, this will be decreases. So this has to be kept in multiplication form. So there is the relation you have to understand. This is the most conceptual thing. When things are related inversely, then by multiplying you have to get the dependent variable. The variation you will get by multiplying the what is the amount that is needed for this variation. What is the dependent variable condition? X minus 2 men doing X days, so one man will need more time. So more means you have to multiply there, because these are inversely related. Now X plus 7 men will do the same job with a lesser time, so this will be divided. But whereas if I see the work, more work, more days, less work, less days. Here less is coming by multiplying. Means if one part is done in A days, so definitely 3/4 part will be done by these days, not A by 3/4. If I do A by 3/4, that will be the more fraction. So lesser work cannot be done in the more days. Lesser work can be done in the, if the strength is same. Okay, so this way you have to understand each and every variables, how it is related to the resultant variable. So if this much work has to be done in 3/4 into these days. Okay, so this is the part which is given in expense. So if I equalize 3 into x minus 2 by 4 into x plus 7, that as per the question is x minus 10. Okay, now calculate this. This will be 3x square minus 6x this side. This will be 4x square minus 10x plus 7x minus 3x minus 12x, 70 to 80. Okay, now rub it out. Now this, if I bring everything in one side, that will be x square minus 6x minus 280 is equal to 0. This is a quadratic equation. So it must have two root. So how will you solve that quadratic equation? 14 into 10. Now 280 is equal to, if I do 2 into 2 into 2 into 3 into 5 into 7, 140, 270, 235, yes. So now I have to bring it such a way that I will get this one. So 7 to the 14, 5 to the 10, 10 to the 20, 20x 40, yes. 20x plus 14x minus 280 is equal to 0, or x minus 20 and x plus 20 and x plus 14 will be the, so x is equal to either 20 or x is equal to minus 14. So minus 14 cannot be taken because this is the quantity which is represented main. So main cannot be negative, so I will adopt this answer. Now x plus 2 is the, x is equal to 20 is the answer, means the value of x for a whole thing. Then how many days will x plus 2 will take? So x plus 10 is how many men? That is equal to 30 men. Okay, now you can take any of this information initially that is given. So that x minus 2 means 20 minus 2, 18 men can do a piece of work in 20 days. So now it is 30 men. So one will do the piece of job in 20 into 18 more days. So now that is 30 is required to do the whole job. Then how many days can this men finish the work? So whole job is 1 is equal to the number of men is increased. So this has to be this one. This will be 12 days. Will be the answer. This is the method of unitary method. You can see this is very much complicated and you need to focus on the variables. Now we'll adopt the second method. As for the second method, we need to know the rate of work, as we can take granted that all men are working in the same rate of work. So from first the rate of work, how they calculate, this man can do a piece of it in x days. So that total work divided by number of men into number of days. This is the efficiency or the rate of work. And if I assume this is rate of work for first case, and what is the rate of work for the second case? They are doing 75%, means 3/4 of the work they are doing. So 3/4 divided by the men is x plus 7 men, and how many days? X minus 10 days. So this will be the rate of work for the second case. Now both all men are having rate of work is same. So this has to be equalized. So from there you will see x plus 7, x minus 10, and this 4 will be multiplied there, is equal to 3 into x minus 2 into x. See, you have the same equation. From there you will get that equation, x square minus 6x minus 280 directly. So we are equalizing the rate of work. Rate of work for first case and rate of work for second case, because this will denote the rate of work of men for second case. This is rate of work of men for first case and second case. So now if we have to equalize, so we will get this equation. Now once you will get equation, there you are getting which one? X is equal to 20 you will get from there. Now if once you will get x is equal to 20, so your rate of work is equal to, from any other equation you will get, that is x minus 2 into x. So this is equal to 1 by 18 into 20. Now what you have to do? The complete work. The complete work is you have to do in how many days? Your rate of work into number of in how many days. So rate of work into the your complete work is equal to rate of work into number of days. So number of days is actually you will get number of men into number of days. Actually they are this much manpower contributing each by day, number of days, because for that time everybody will for those days. So one person can contribute d days, so this much person will contribute this days. So total this one, so rate of work is equal to 1 by 18 into 20 into this is 30 into d. So what is your d? D then is equal to 18 into 20 by 30. So now you can see which one is the best method, that is you have to decide and you have to adopt. Okay, so this is very straightforward method and you can I think you can do very easily by this method. So that's why I want to show you both the things so that you can distinguish and can adapt and can take your decision which way you want to proceed. So now the problem number is 30. It says a contractor employed a certain number of workers to finish constructing a road in a certain scheduled time, sometime later when a part of work had been completed, part of work had been completed, he realized that the work would get delayed by 3/4 of the scheduled time Okay, so he at once doubled the number of workers and thus he managed to finish the road on the scheduled time. How much work he had been completed before increasing the number of workers. Okay. So the problem is being very lengthy. So let us understand together. A contractor employed a certain number of workers to finish constructing a road. This is the job, constructing a road, a unit job, whatever with the size of the job, it is a one job in a certain scheduled time. So what he has done, he employed certain number and there is a time frame, there is a bound time frame within which he has to complete the road. So first pre-assumptions for us, number of men is M, number of day V the D. These two are unknown, so this we are assuming this number of men as per his assumption to complete the road is M and the scheduled time is given is D. Fine. So this is first part. Okay, this is part A. Sometime later, when a part of work had been completed, so in the part we said, sometime later, let be a part X is completed. Okay, completed. He realized that the work would get delayed by 3/4 of scheduled time. So the remaining job with this man force, he will not able to complete. So what he is realized that if he is going with this manpower, the whatever the job he has done, the remaining job, that means 1 minus x, that cannot be done in the stipulated time, the remaining time, because let's say this x that part is done in D1 with manpower M, the remaining job is 1 minus x, that cannot be completed in D minus D1, the remaining day, with this manpower. Okay, so this is the realization he is having. So what he after realizing, what he does, so he at once double the manpower. So that in part C, what he does, he has doubled the manpower. Why? To finish the remaining job. That means the part of job he has done and the remaining job, this is part C. With this time frame he has to complete, he doubled the manpower. Okay. Otherwise, with the same manpower M, he would have done the job in D plus 3/4 of D time, the complete job with the manpower. So actual assumption initially that with the M manpower and D time he can complete, that goes wrong. The actual target that should be calculated before starting with the M manpower in the number of days this much. So then he can complete with the rate of job. So these are the scenario. Now you see, with the assumptions what he has assumed to complete, with that assumption he has done some part of job. So during that, if I calculate his rate of work, now see, this is very important to understand the part initially where that goes wrong. Till now, whatever we did in the earlier problem, there for the full job, the rate of work is followed the same. Now, here with the wrong assumption, the rate of work will be dependent on M and D. This, but after doing some work, his assumption goes wrong and his rate of work by which he can, if he follow the same rate of work, cannot achieve his target in these remaining days. So he changes his rate of work by doubling the manpower. So there again rate of work is changing. So in the complete job, some part he is doing with M manpower and with the D day assumed date, and with the next part he is doing M manpower with the assumed date the date of completion is D. So this is improvising. So improvising is that this is the day will follow the rate of job. Here the day will follow D1, means with the pre-assumptions with M manpower D for the complete span. That goes wrong after doing some work, this part of job. He has realized that unless he increase the manpower, he cannot achieve in remaining day. So he is not varying the day, whereas he increase the manpower. So the first part he is doing with M manpower and doing for D1 days, let's say, is doing that part of job. And then next, the remaining day is D minus D1, then the number of days will be D1 plus D minus D. So that is the complete day is same, but he is changing the manpower. So here rate of job is different. So for completing the same job, he is increasing the rate of, means is varying the rate of work. So that cannot be same rate of work we can calculate. But what the other information is saying, if he follows with the M manpower instead of D, the correct time would be 1 plus 3 by 4 of D. If this is the equation, their rate of work would be steady and uniform throughout the work, but here number of days will increase. So this is the true scenario, but thing is that the manpower whatever is engaged, if I consider individual manpower, their efficiency is same. Only thing is that time calculation goes wrong. Okay, so with this information, whatever the efficiency I will calculate, the people's efficiency, and with this information, whatever efficiency I will calculate, those must be same. Understood? So here I am varying the efficiency by increasing the manpower, and here I am increasing the number of time. So with both variation, your total target is same, 1. Here you are increasing the manpower, varying the manpower, here you are varying the time, but ultimately the your efficiency of per person will be same. So if I can conclude this, so in both cases what would be the rate of work? So rate of work when we are varying, when we vary manpower. Okay, so so total work is 1. So first part of the job, the manpower used is M. We have assumed that they did for D1 days. So this will be M into D1, that is the total fraction of that time consumed here. What is that? I need rate of work. So that means job divided by the time, total time, and total time is depends on the manpower engaged, and each member is contributing for D1 days, and second half manpower engaged and each member is contributing for D1 this much days. This is the first rate of work. In second part of the rate of work when time varies, time is varied. Okay, or you can say varying time, where rate of work is equal to the complete job is here is also 1 and manpower is same. Only thing is I am varying the time. Why I am saying varying the time? What he has realized? He realized with the same work would get delayed by 3/4 the scheduled time. When? If he can follow the same manpower without improvising the manpower, he need total time is 3/4 than the scheduled time. So this is the time 1 plus 3/4 of D will be delayed. That means 3/4 further delays from the scheduled time. So 3/4 of what? Of the scheduled time. So D plus 3/4 of D. I have taken D common. So this is the second rate of. So in both cases, this is denoting the efficiency of the person working there. The same set of manpower, same set of people are used in varying condition. The one condition there time is varied, another condition manpower varied, but efficiency wise both are same. Now these are denoting the efficiency of the person. So this can be equalized. Remove the boundary in between and you can equalize this. So if I equalize, there is a 1 on the numerator, the denominator should be same. So I am removing all this extra line and number. I am just equalizing this. What I am equalizing, m into this. If you calculate, it should be 7/4 of D ultimately. So my task from here to get D1 in terms of real D. So I will remove all m because everything is multiplied the same way in the left and the right hand side. So this is D1, I am putting it here, D1 plus 2D minus 2D1 is equal to 7/4 D. Okay. So this is what 2D minus D1 is equal to 7/4 D. So that implies D1 is equal to 2D minus 7/4 D. That is equal to how much? 1/4 D. So D1 is the day taken before increasing the doubling the manpower. So this is D1. So what fraction of job they did? If the fraction of job, now this is I am removing, or what part of job? The part of job done before increasing manpower is equal to what? The fraction of job that they did is equal to D1, fraction of job done is equal to the rate of job, that is m into D, isn't it, into what I have calculated there, 2D minus 7/D, the fraction of job they did, m into D into m into D1. So that is equal to mm will be cancelled out, D1 by D. That will be the case. What I have calculated there, the equation I forget, that is equal to D1 plus 2 into D minus D1, and that they did in 7/4 into D. So that becomes 2D minus D1. That means D1 is equal to 1/4 D. 1/4 D. D1 is the dead. So fraction of work. So at once, okay, fine. So completed before it increasing increase the number. So what is the requirement? So at once he has finished. So and this was managed to finish the job on scheduled time. How much work he had been completed before increasing? So how much work he has been completed? That means the rate of work rate of work should be this is D1 minus 1. Rate of work is how much? For the first case, rate of work is m into D1 plus 2m into D minus D1. This is the rate of work for first case, and he did m into D1 part. So this is the rate of work into the day, complete number of day when m is only there. So before changing only m manpower has worked and what many days d1. So this is the time consumed with the rate. So rate of work into the time will be the fraction of job being done. So d1 is a, now here it is m will be cancelled out. So m I will remove. So this will become d1 into ultimately 2d minus d1 will be here, isn't it? M cancelled at d1, 2 into d minus 2d1, that is equal to 2d minus d1. This will be the equation fraction of job they did before changing the manpower, isn't it? You understand? This is the rate of job for first case. First case, what is the complete job and the total time? Total time is this plus this total time. So now if we put d is equal to d by 4 there, so this is equal to d by 4 upon 2d minus d by 4. So ultimately this will become d will be cancelled out because there is this is 4 to the 8. So this is 1 by 4 to the 8, 1 7 by 4. So ultimately this is 1 by 7 part. So after 1 by 7 part of doing, he has realized and he has increased the manpower. So just go through the problem very sincerely, because there are always a chance of making mistake. So the rate of work is very essential or crucial here. I cannot do it with a unitary method because that will be more clumsy, that will be more difficult to understand. Rather, if you follow this process, will be at least you can grasp the variation. Okay, so better follow this process. Okay, and if you want to try it with unitary method, you can try and test me. Okay, if you stuck somewhere, then just tell me. I can give you some hint and I can solve it for yourself even if it is needed. But as of now, just try to understand. This is a very good problem. If you having concept, then only you can go ahead with this process. Okay, so I will end up here. This is being long. I will move on to the problem number 31 in the next video. Till then, thank you. Bye bye.